Welcome to this session. In this session, we are going to discuss about the first shift property for Laplace transforms, and then do some examples related to that property. So let's So the shift property for Laplace transform states that, statement, that if the Laplace transform of a function f of t is given by capital F of s, then the Laplace transform of e raised power minus at multiplied by this function f of t is given by capital F of s plus a. So where a is a constant. So that's the statement of the first shift property, that if the Laplace transform of a function f of t is capital F of s, then when you multiply this function f of t by e raised power minus at, the Laplace transform of this new function is capital F of s plus a. So quick proof. So we know that Laplace transform of f of t is given by the integral from 0 to infinity e raised power minus st multiplied by f of t dt. And so this is what we also represent it as capital F of s. Now, when you multiply e raised power minus at times f of t, then Laplace transform of e raised power minus at times f of t would be given by integral from 0 to infinity e raised power negative st. So the place of ft, the function, we have e raised power minus at multiplied by f of t, then dt. This by definition. Now, this part, we write integral 0 to infinity e raised power. So here we factor out negative, and then we have s plus a, and then multiply by t, f of t dt. Now, this is actually the definition of the Laplace transform of s plus a. So this integral defines the Laplace transform of e raised to minus at f of t, and is equivalent to capital F of s plus a, since we know that capital F of s is integral from 0 to infinity e raised to power minus st, and then f of t dt. So the role of s in this definition is taken by s plus a. So that's why we have this result. Now, an example. Example 1. A, find the Laplace transform of the function f of t given by t sine of 5t. So that's the first part. And then after getting the Laplace transform, part B, use the shift theorem to find the Laplace transform of e raised to minus 3t sine of 5, so times t sine of 5t. So to solve this problem, we remember from the table of Laplace transform. So solution, part A. We know that Laplace transform of a function t times sine of bt, where b is a constant, is given by 2bs over s squared plus b squared squared. So this is the result from the Laplace transform tables. So in our case, we are interested in finding, so this is a solution to part A, Laplace transform of t sine of 5t. That's what we have to evaluate. So in this case, we see that b is 5. So the result will be, this implies, so result will be 2 times 5, which is our b, s divided by s squared plus 5 squared, and then squared. So therefore, the Laplace transform of t sine of 5t will be given by 2 times 5 is 10, so 10s over s squared plus 25, and then you square the sum. So this is the answer to the first part. And this implies that f of s is given by 10s divided by s squared plus 25. Then you square this. Now, the second case, part B, we know that if the Laplace transform of f of t is given by capital F of s, then the Laplace transform of e raised to power minus at times f of t is given by capital F of s plus a. This is according to the first shift theorem. Now, our problem is to evaluate Laplace transform of e raised to power minus 3t t sine of 5t. So in this case, our f of t is t sine 5t. So here, if we compare this and this one, we see that a will be the same as 3, and f of t is the same as t sine of 5t. So therefore, according to the first shift property, we have Laplace transform of e raised to power minus 3t t sine of 5t will be capital F of s plus a is 3. Now from a, since capital F of s from part A is given by 10s over s squared plus 25 squared, then capital F of s plus 3 simply the role of s in this one will be taken by s plus 3. So this will be 10 into s plus 3 divided by s plus 3 squared plus 25, and then you square this result. Now this one you can simplify further as capital F of s plus 3 equals to 10s plus 30 divided by, so s squared plus 2 times 3s, which is 6s, plus 3 squared is 9, and then plus 25. Then you square this, which is the same thing as capital F of s plus 3 is equals to 10s plus 30 divided by s squared plus 6s. Now 9 plus 25 is 34. And then we square this denominator. So this will be the answer to the second part. Last problem on application of first shift property. Example 2. The Laplace transform of a function f of t is given by capital F of s equals to 2s plus 1 divided by s into s plus 1. State the Laplace transform of these two functions, a e raised power minus 2t times f of t, and b e raised power 3t times f of t. So this is the next question. Now, the first part, a so since when Laplace transform of f of t is given by capital F of s, then Laplace transform of e raised power minus at times f of t is given by capital F of s plus a. We have a equals to 2. Now just relate e raised power minus at and e raised power minus 2t tells you that a is 2, which implies Laplace transform of e raised power minus 2t times f of t will be given by capital F of s plus 2. Now, we have already been given f of s, so which means f of s plus 2 will be easy to find by simply taking the role of s to be s plus 2. So this implies that Laplace transform of e raised power minus 2t f of t will be f of s plus 2, which will be given by 2, where this s we put s plus 2 plus 1 divided by s plus 2, and then into s plus 2, and then plus 1. We are simply taking the role of s to be s plus 2. Now expanding this, we will have capital F of s plus 2 equals to 2s plus 4 plus 1 s plus 2 s plus 2 plus 1. On simplification, this implies Laplace transform of e raised power minus 2 s 2t f of t will be given by 2s plus 5 divided by s plus 2 into s plus 3. So that is the result for that first part. And then part B, we have to calculate Laplace transform of e raised power 3t times f of t. Now, also, we know that given Laplace transform of f of t is given by capital F of s, then Laplace transform of e raised power minus at f of t is given by capital F of s plus A. Now, in this case, A, you see, just let e raised power minus 3t, and then you equate it to e raised power minus at. This tells you that 3t equals to minus at, which tells you that a is minus 3. So in this case, a is minus 3. So therefore, Laplace transform of e raised power 3t f of t will be given by capital F of s, the place of a is minus 3. So since we have been given f of s, then this implies that f of s minus 3 will be given by twice s minus 3 plus 1 over s minus 3. So the role of s in the general f of s is taken by s minus 3 into s minus 3 and then plus 1. So in simplification of this, we get capital F of s minus 3 is equals to 2s minus 6 plus 1 divided by s minus 3 into s. So minus 3 plus 1 is minus 2, i.e. the Laplace transform of e raised power 3t times f of t will be given by 2s minus 6 plus 1 is minus 5 divided by s minus 3 into s minus 2. So this is the answer to the second part. Now in the next session, we'll be discussing about the second shift property or the second shift theorem, and then do an example to illustrate how it's applied. Thank you.